All right. So all this is today's lesson 7-9, it's just, quiet please, it's just special cases of what we already did on Wednesday. So there's some formulas on here that you can use or whatever, or that I could write down for you, but I'm not going to bother. We'll just do them like we did it on Wednesday. It's the same thing. So we're going to go right to example number 1. So again, there's a lot of glare up there on the board, but hopefully you guys can see that. So on number 1, well, how do you do x plus 3 squared? What would you do? From Wednesday, what would you do? It's the quantity x plus 3 squared, so how do I do it? What's that, Tom? Yeah. Yeah, Tom just said you do x plus 3 times x plus 3, right? That's what it means to square something. It means times itself. So we're just going to do the quantity x plus 3 times the quantity x plus 3. Ethan, you need to put that away, all right? All right, so same thing we were doing on Wednesday. We're going to distribute this x onto both of these terms in that second binomial. And then we're going to distribute the positive 3 onto both of those terms. All right, so in the blue here, what's x times x? What is it? X to the second power, yes. Yeah, it's not 2x, okay? It's not x plus x. It's x times x. So it's x squared. And then we've got to do the x times the positive 3. So what's that? The vase says 3x. Good. And then in the red, well, then we got to do a positive 3 times x. 3x. That's another 3x, right? So it's another positive 3x. And then we got to do the positive 3 times the positive 3. What's that? 9. Yep, positive 9. So it's positive 9. And then same thing we did on Wednesday. You can add these two terms in the middle. But do you notice it's just that it's the same term, right? It's 3x plus itself. Well, that's going to happen on all of these today. At least the ones that are, we've got the square, on the ones where we have the square of a sum like that, those two terms in the middle are going to be identical. So then we end up with x squared. Well, what's 3x plus 3x? Yep, that's a positive 6x. And then plus 9. And that's it. So nothing new. We already did this on Wednesday. This is just a special case of what we already did. Let's go to number 3. So number 3, we're going to do the same thing. It's going to be the quantity 5 plus m squared times itself. Like that. All right, so same thing. We're going to distribute this 5. And then we're going to distribute this m squared. So just like on Wednesday, this is like doing the distributive property twice. So in the blue, I got 5 times 5. That's 25. And then I got 5 times m squared. Good. 5m squared. And then in the red, I've got m squared, a positive m squared, times a positive 5. Yeah, I mean, it's m squared times 5, but you're going to write it as 5m squared. So that's another positive 5m squared. And then at the end there, we got a positive m squared times a positive m squared. Well, that's going to be a positive, what? M to the what? What was that? Who said that? Sydney? That's good. Yes, m to the fourth. If you do m squared times m squared, you gotta add the powers, right? So it's m to the fourth. And now, do you notice that these things in the middle here, these two terms are not only can you combine them, like you could on Wednesday, but they're identical, right? It's the same term. It's a 5m squared and a 5m squared. So you add those together, what do you get? Yeah, you get 10m squareds. And then you bring down the plus m to the fourth. And then you bring down the 25 in front. And that's it. That's not too bad, right? What's up?
I thought we had to put them in order.
Yeah, that's true. That one would not be in standard form, right? But I'm going to leave it for now. Aiden, that's good. Aiden,
Just talking to you.
Aiden, that's good.
What?
That's good.
Did I know that?
Yeah,
Yes.
yeah. All right, enough.
I don't get it. Why are we clapping? Yeah, why are we clapping?
Because Aiden was paying attention.
Whoa, that's a once in
All right. Come on, I'm recording this. Quiet, please. So I'm going to do number 4, all right? What's the difference in this one? Yeah, it's got a subtraction in there, right? It's a binomial. It's got a minus in the middle. But we're still going to do it the same way. We're going to do the quantity x minus 6 times the quantity x minus 6. Bless you. Again, stop the side conversations, please. I am recording this. So same thing we did before. So in the blue, I got x times x. Yep, x squared. Then I got x times negative 6. Negative 6x. Then in the red, I've got negative 6 times positive x. What's that? Negative 6 right here. Negative 6 times the positive x. Yeah, negative 6x again. And then finally, I got the negative 6 times the negative 6. Good, Ethan. Positive 36. Now, do you notice the same thing's happening here, except these terms are now negative instead, right? So you still combine like terms in the middle there. You can add those. Well, actually subtract them, but they're identical, right? It's negative 6x and negative 6x. Same thing that happened on numbers 1 and 3. So then, what's negative 6x take away 6 more x's? What's that? Yep, negative 12x is good. And then you bring down the 36. And you bring down the x squared. There you go. Very exciting. All right, number 5. Let's do that one. I think we'll skip 6. Let's try this one. So we're going to do the same thing again. We're going to do 2x minus 5y. We'll do that quantity times itself. All right. So we're going to do the 2x times both of these terms. And then we're going to do the negative 5y times both of these terms. So again, all we're doing here, just like Wednesday, is we're just doing the distributive property twice. So we start out in the blue here. We got 2x times 2x. 4x what? Squared. Yeah, you do 2 times 2 would give you the 4. And then x times x would give you x squared. Then we're going to do the positive 2x times the negative 5y. So 2 times negative 5 is? You guys gotta help me out. What's 2 times negative 5? What's that? Good, negative 10. So negative 10, and I still have the x times the y. So that's going to give me an xy. And then in the red, I'm going to do a negative 5y times a positive 2x. So, yeah, good. Kyle, that's good. Yeah, it's going to be negative 10 again times y times x. But y times x is the same thing as x times y. So you're going to, again, the normal convention is to write the letters in alphabet or the variables in alphabetical order. So that's going to give you another negative 10xy. And you already knew that these things had to be the same, right? That's what I've been telling you. You knew that in the middle of this thing, these two terms, these were going to be identical, these two. They're both negative 10xy. If that doesn't happen, you know you messed something up. And then the last multiplication we got there, we got to do the negative 5y times another negative 5y. Good. Ethan said, well, negative 5 times negative 5 would be a positive 25. So you got a positive 25. And then you got a y times a y, which would be y squared. And then same thing as before, you're going to add these two terms in the middle. So what's negative 10 xy's? Take away 10 more xy's. Good. Lucas, was that you?
Yeah.
That's good. Lucas, that was good. So negative 20xy in the middle. We bring down the 25y squared. Lucas, do we need to clap for you also? Or are you okay?
I would like it.
You would like it? Okay, all right, he wants to be clapped for. All right. All right, and then also bring down... That was enough. This is not supposed to be fun, all right? So then bring down the 4x squared out in front. And there you go, that's that one. All right, so I think that'll take care of that. Those two types. That's the square of a sum and the square of a difference. Let's look at the last three. Well, what is different about this one? Yeah, perfect. Like all the other ones we did, you know, if this was a plus, then this was a plus, right? Or if this was a minus, then that was a minus. But now we got two binomials here. One's got a plus in the middle. The other one's got a minus in the middle. So let's see what happens with this. Now, are we getting to the point where I can stop drawing these arrows every time or no?
Yes.
Yeah.
I can.
Those arrows kind of I don't like arrows.
All right, let's try it without the arrows, all right? All right, so we're going to start out, we're going to do x times x. Kids? X times x. X squared. Yes. Shh. Yeah, don't say x2. It's x squared or x to the second power. All right. Then we're going to multiply these two together. X times a negative 4. Good. So that's negative 4x. Then we're going to multiply together the positive 4 with the positive x. That's a positive 4x. And then we're going to finish by multiplying the positive 4 times the negative 4. Good. Who said that? Aiden, was that you again?
No.
Yeah.
Now, on this one, guys, what happens in the middle on these now?
They cancel out.
They cancel out and make 0. All right? Negative 4x plus 4x, that's 0x. And 0 times x is just 0. So they cancel out. That's just 0.
Are they gonna cancel out every time?
Yep. As long as it's two binomials that are identical, and one's got a plus in the middle and the other one's got a minus in the middle. So the final answer is just x squared minus 16. All right. Let's do another one. So this one, again, without the arrows here then, p squared times p squared. Yep, p to the fourth. And then we're going to do the p squared times the negative 8q. P squared times negative 8q.
Negative 8q to the second power.
Not quite. Negative 8 what?
8q.
8q p to the second.
Yes. Shh, quiet, yes. It's negative 8 q times p squared, but normally, again, we normally put the variables in alphabetical order. So it would be a p squared q. So negative 8 p to the second, what am I lost it in q, right? All right. And then we're going to do these two terms, the positive 8q times the positive p squared. What's that? 8 what? Yeah, I mean, it's 8q p squared, but again, we're going to write it in alphabetical order, so it's the letters or the variables in alphabetical order. So it's going to be a positive 8 p squared q. And then, look, we knew this was going to happen anyway, right? These two terms, look at these two terms, these are going to be identical. One of them is going to be a plus and the other one's going to be a minus, and they're going to cancel out every time. Hold on. Let's finish this. So then we didn't finish. We still got to do the positive 8q times a negative 8q.
Oh, negative 64q squared.
Good. Yep, positive 8 times negative 8 is a negative 64.
Oh.
And then q times q would be a q squared. And again, these cancel out in the middle, make 0. So the final answer is just p to the fourth minus your mom squared.
Oh, your mom. Wait, what?
What's it do?
My mom's good. Oh,
All right, so p to the fourth minus 64q squared. All right, last one. All right, you guys help me. What do I do first? Dewan, you know, what do I do first? Somebody give me a first step. Raise your hand. Raise your hand. Hold on. You didn't raise your hand. Aiden, you raised your hand. What do we do? What is that? What's that? 100? All right. The next step, Dewan, you got it? Good. Yep. Negative 10b. Who's got the third step? Who's got the third step for me? All right, Aiden, you already went. Rachel, what do you got?
10b.
Yep.
10b.
Yep, plus 10b. Who's got the last one? Kyle, you got it?
Yes, you do.
Aiden, I know you got it, but I want to get somebody else. What's the last step, guys? Raise your hand. Ethan, what do you got? Yep. Minus b squared, right? Because you would do the positive b times the negative b. A positive times a negative is a negative. And a b times a b is a b to the second power. All right? And then these cancel out. That's just 0. And you get your final answer. So you get 100 minus b squared. So then you stick that in your juice box and suck it.
Grab a straw. You suck. It's freaking nasty, bro.
There you go.
I like the
So you got the correct answer, so now you're happy. Are you happy? Look at Aiden's happy. All right.
I'm happy because I actually know what I'm doing.